Imagine holding a tiny computer chip, a microcontroller, wondering how its many legs connect to the digital world. Each of those pins has a specific purpose, and understanding them is key to making your projects work. Reading a microcontroller pinout diagram essentially means deciphering a visual map that connects the physical pins of the chip package to their corresponding internal functions and electrical characteristics. It is your essential guide for connecting external components and programming the device. These diagrams are critical because microcontroller pins are not just simple input or output lines. They are highly versatile and often multiplexed, meaning a single physical pin can serve multiple functions depending on how you configure the microcontroller. Understanding the diagram helps you correctly identify power supply pins, such as VCC and ground, which are crucial for powering the device. You will also find general-purpose input-output pins, commonly known as GPIO, which can be configured as inputs to read sensors or as outputs to control LEDs. Furthermore, pinout diagrams detail special function pins that are dedicated to specific communication protocols or peripherals. These include universal asynchronous receiver transmitter pins for serial communication, serial peripheral interface pins for high-speed data transfer, and integrated circuit pins for connecting to various sensors. Many pins also offer alternate functions, like using a GPIO pin as a pulse width modulation output for motor control, or as an analog to digital converter input to measure voltage. Each pin's role is defined by its label and the surrounding annotations in the diagram. To effectively read a pinout, always begin by locating the physical pin numbering on the chip package, typically starting from 1 and proceeding counterclockwise from a reference point. Then, cross-reference these numbers with the diagram to identify the primary function of each pin. Pay close attention to any multiplexing information, which usually appears as secondary labels or in an accompanying table, indicating what other functions a pin can perform. Carefully noting the voltage requirements for power pins and the current limits for output pins is also vital to prevent damage to your microcontroller. Mastering the skill of interpreting a microcontroller pinout diagram transforms a complex web of connections into a clear, actionable plan for your embedded projects. It empowers you to confidently design circuits, write code, and bring your digital creations to life by correctly interfacing your microcontroller with the outside world.